Welcome to the third and final part of our lecture on interfaces in C#. In this section, we'll explore the most widely used interfaces in the .NET framework, such as iDisposable, iEnumerableT, iComparableT, and many more. We'll look at concrete implementations, walk through code examples, and understand how these interfaces contribute to clean, reusable, and efficient programming. Let's begin by recalling how interfaces enable polymorphism in real applications. Here we revisit polymorphism using the iWorkable interface. 3 different objects, a dog, a cat, and an employee, all implement iWorkable. By placing them in an array of iWorkable and calling work, we get the appropriate behavior for each. This illustrates the power of interfaces. We write one loop and it works for all objects, even if they're from unrelated class hierarchies. This example shows a iLogger interface with the default method logError. It internally calls log with a formatted error message. The FileLogger class implements only log. This approach allows us to add new functionality to an interface without breaking existing implementations, key for backward compatibility and evolving APIs. A few reminders for designing interfaces. Keep them small. 1 job per interface. Name them clearly. Always prefix with I. Be consistent and use abstract classes only when shared logic is required. These principles support modularity, testability, and scalability. Quick recap. Interfaces equals contracts that enable multiple inheritance and polymorphism. Abstract classes equals shared logic but with single inheritance. Use interfaces for flexibility, abstract classes for commonality, and remember that default interface methods allow evolution without disruption. Now we look at some of the most important interfaces in the .NET framework. In the following, think of T as a blank type. I don't know what type I need yet. I'll decide later. T allows you to define generic classes, methods, interfaces, or delegates, where T acts as a placeholder for a data type that is specified later, at runtime or compile time. iDisposable is crucial for resource cleanup, ensuring that unmanaged resources are released properly. iEnumerableT allows for easy iteration over a collection, making it simple to traverse data structures. iComparableT is used for sorting, enabling objects to be compared and ordered effectively. iCollectionT, iListT, and iDictionaryTkey, T-value provide robust collection management, each serving unique purposes for handling groups of objects. iNotifyPropertyChanged allows objects to notify clients, typically binding clients, that a property value has changed, which is essential for UI updates. iEquatableT provides a method for determining equality between instances of a type, enabling efficient comparisons in collections and link queries. iEqueryableT represents a collection that can be queried using link, enabling dynamic query generation and execution against data sources. iObservableT defines a provider of push-based notifications, facilitating the creation of asynchronous streams and reactive programming patterns. iDisposable is essential for releasing unmanaged resources. This example defines a resource manager class that wraps a file stream and disposes it in the dispose method. By using a using block, the system ensures proper cleanup, preventing memory leaks or file locks. This is critical in file handling, database access, and system I/O. To make a custom class iterable using for-each, implement iEnumerableT. In this custom collection T class, items are stored in a private list. getEnumerator returns the list's enumerator. This enables link support and collection traversal. Mastering this pattern makes your classes collection-aware and queryable. Use iComparableT to enable sorting of custom objects. In this example, person objects are sorted by age using the compareTo method. Age comparison determines the order. Once implemented, you can use sort directly on a list of persons. This is a core feature for data structures and UI sorting logic. iNotifyPropertyChanged is crucial in user interface frameworks like Windows Presentation Foundation and Model View ViewModel. It signals when a property value changes, enabling automatic user interface updates. This ViewModel class shows how to trigger the property-changed event whenever name is updated. This interface forms the backbone of data binding in modern user interface frameworks. iObservableT supports the observer design pattern. It enables push-based notifications to subscribers. In this stock market example, multiple observers receive price updates. A nested unsubscriber class handles removing subscribers. This pattern is foundational in reactive programming and event-driven systems. aQueryableT is used for querying remote data sources, such as databases. It supports link to SQL or entity framework queries. This example shows a link query that filters people older than 25. The actual execution is deferred until toList is called, allowing query composition and optimization by the provider. iClonable allows you to duplicate objects. In this clonable object class, the clone method returns a new instance with copied values. It's useful when you need to preserve original state before making changes. Need custom formatting for toString or string format? Implement iFormatProvider and iCustomFormatter. Here we customize integer formatting by intercepting formatting calls. This pattern supports localization, financial formatting, and logging scenarios. To wrap up this part, remember these best practices. Use iDisposable for resource cleanup. Implement iEnumerableT to support iteration. Use iComparableT for sorting logic leverage. iNotify property, changed in UI-bound models. Apply iObservableT in push notification systems. These interfaces are foundational. Mastering them unlocks real-world coding power. Let's conclude with the key takeaways. .NET interfaces provide standardized abstractions for common patterns like iteration, comparison, formatting, and event notification. Interfaces like iDisposable, iEnumerableT, and iComparableT are everywhere in real-world projects. These interfaces boost modularity, maintainability, and extensibility of your code. They are the silent enablers behind robust .NET applications. This wraps up our comprehensive journey through interfaces in C#. From understanding their theoretical foundation to applying them in polymorphism, implementing real-world interfaces, and following industry best practices, you now have the tools to write more flexible, reusable, and professional-grade C# applications. In upcoming lectures, we'll continue this architectural momentum with topics like dependency injection, solid principles, and design patterns where interfaces play a central role. Until then, keep practicing and designing with intention, because great software begins with great abstractions.